Hi, I am Muhammad Mawardi bin Hussein from KKTM Sri Gading Green Building Department. Today, I would like to share upon this Green Technology Park with you all. Okay, our Green Technology Park consists of 3 major prestigious buildings. Starting from STU1, my far left, Simulation Training Unit 1. Okay, followed by STU2. Next to STU1 is STU2 Simulation Training Unit 2. And lastly, behind me is the Solar Park. These 3 prestigious buildings that we develop in this Green Technology Park is preparation for the student, so that the lecturers' deliverable will be balanced between practicals and theoreticals. Okay. Without further ado, I would like to invite my colleagues from Green Building Department, Mr. Fakri bin Muhammad Yaakob, to present upon on the STU1 Simulation Training Unit 1.
Okay, thank you Mr. Mawardi. Today I would like to show you one unique building in KKTM Sri Gading, what we call also as a Simulation Training Unit 1 or ST1. ST1 basically is a 20 feet of container, and we turn it into a building, or what we call also as a mini office. This building design basically has been designed for their passive design concept, their building characteristic, and their building material. This allows students to take a measurement of data for their courses and their study. Let me show you what inside. Let's go. From the inside, this wall has been insulated by this material. This is what we call a cellulose fiber. The cellulose fiber basically is made from shred paper, and we add with some chemical for their fire resistance, and we fill in to this ball by using a blowing machine. The process of using this blowing machine are learned in the subject of passive design concept. Other than that, this is one of the achievement we have here, which is this STU has been published in one of the Malaysian newspaper, and they said more on how this 20 feet of container became a building. For a measurement part, we have here we call as a thermocouple. Basically, a thermocouple is we want to measure the surface temperature, and then the purpose we use this because we want to improve their thermal conductivity and thermal transmittance through this wall. Other than that, this thermocouple has been connected by this data logging system or data logger. This data logger has been connected with this thermocouple, and the data we can set the interval of data, and then we can create a 24-hour profile of temperature data. This temperature data is important in designing of cooling load and designing or sizing of air conditioning system. Last but not least is the last device, what we call as a globe temperature. This globe temperature basically we want to measure radiant temperature from outside and inside to the building, and then this device also has been connected by using a data logging system. That's all from me. I will pass to Mr. Mawardi for the next explanation. Thank you.
This is STU2 Simulation Training Unit 2. Okay, this STU2 will built by container. Okay, the container we turn it into Soho house. Soho meaning small office, house office. This Soho is a special design, which is we are implemented the passive design concept in it. Why we introduce the passive design concept? Because as a sustainable development building, we want to reduce as much as heat possible coming into this house, so that the cooling load in the building will be lower. Thus, the energy to air condition the STU2 will become lower compared to the conventional building. Okay, without further ado, let's go inside and discover it together. Here we are inside the STU2 building. Okay, for your information, this STU2 wall, okay, were made by this thermal insulation system. Okay, this thermal insulation system consists of the outer part is the container. Okay, and then we have a insulation in the middle, and we have plywood, and we also put the styrofoam, and inner part we flush with this cement board, okay, and paint it back. Okay, this thermal insulation system will apply because of we want to improve the thermal performance of this building. By improving the thermal performance of the building is by lowering down the thermal transmittance value, that is the U value. So thus the cooling load of the building by the external heat load will be reduced. As we know, this building will apply the thermal insulation system and we want to improve the thermal performance of the building. It is vital to have this kind of device. There is a thermocouple. Okay, we have a thermocouple for the student to study. This thermocouple we install so that the thermocouple can read the temperature, surface temperature of the wall inside, and also surface temperature of the wall outside. So it works simultaneously. Okay, because we want to work simultaneously, we want to read the instantaneous heat transfer from outside to inside. That is we apply on this practical on the building and on the passive design practical. And then also for the thermal light component, we assist that temperature outside to the inside by thermal light medium. We can see by the cooling load profile that we'll discuss after this. Okay, beside that, we also have the temperature and humidity sensor, also the CO2 carbon dioxide sensor. So this sensor were very important to measure the thermal comfort in this building, especially humidity and CO2 levels. Okay, now we go to the next device. That is data logger. As you can see, this is the energy data logger. This energy data logger is very important for the subject of building energy analysis. The student of building energy analysis will collect this energy consumption data. For example, currently there is a 0.139 kilowatt. There is a 139 watt of power that we are consumed in this building. So this instantaneous watt will change to the data energy profile. Then in the energy profile in kilowatt hour, the student will put this energy profile in terms of graph, and they will study the technique of the energy conservation on how to reduce the energy usage. Those will reduce the building energy saving cost. As a conclusion, behind me is the STU1 and STU2. STU1 is the mini office house, and STU2 is the Soho house, small office house office. These Soho are intended to be a zero net energy houses. The zero net energy houses because of we are installed 3 kilowatt peak solar PV there at STU2. STU2, all the electrical load will be covered by the solar PV. To be a zero energy house, all the energy consumption must be covered by solar PV. Last, I will pass to, or also I will invite to Mr. Hanif to explain more on the solar park.
Okay, thank you, Mr. Wadi. Now we are in Solar Park KKTM Seri Gading. Now let me introduce the system in here. On my right is building integrated PV system, which is generate 4 kilowatt peak energy with polycrystalline solar module. On my left is retrofitted system, which is generate 4 kilowatt peak energy by using monocrystalline PV module. The third one is on the ground is solar freestanding system, which is generate 4 kilowatt energy by using polycrystalline module. And the last one is hybrid system, which is 6 kilowatt peak and generate 6 kilowatt peak energy by using polycrystalline PV module. In front of me is weather station, which is measure rain, irradiance, wind speed and ambient temperature. Building integrated PV system, 4 kilowatt peak grid connected PV system. Use polycrystalline PV module to generate 4 kilowatt peak energy, called as BIPV because the solar module acts as roof. It has a drain in between solar module to ensure no leakage. This BIPV system was attached with single-phase grid from utility provider. In Malaysia, we call it Tenaga Nasional Berhad (TNB). This area developed for students do their practical in installation and wiring the single-phase electrical system such as inverter, AC combiner box, DC combiner box, and meter. Retrofitted PV system, 4 kilowatt peak grid connected PV system. Use monocrystalline PV module to generate 4 kilowatt peak energy, called as retrofit because the solar module mounted on roof. It has a special bracket to hold the solar module unit. This retrofitted system has attached with single-phase grid from utility provider. In Malaysia, we call it as Tenaga Nasional Berhad (TNB). This area was developed for students do their practical in installation and wiring the three-phase electrical system such as inverter, AC combiner box, DC combiner box, and meter. Freestanding PV system, 4 kilowatt peak grid connected PV system. Use monocrystalline PV module to generate 4 kilowatt peak energy, called as freestanding because the solar module mounted on the open structure. All the equipments are protected with index protection IP65. This freestanding system was attached with three-phase grid from utility provider, Tenaga Nasional Berhad (TNB). Now, this is a few instruments for measurement purpose in solar photovoltaic installation that we have in Solar Park KKTM Sri Gading. Starting with solar PV analyzer. Modern technology to measure the performance of PV system after installation. Complete with soil sensor, this equipment measure and map VMP and IMP. The graph will produce after measurement is completed. The second one is Sun Eye. This equipment used to cater solar shade by key in latitude and longitude into the device. The result, it can analyze the shade for annum at targeted area. Number 3 is clamp meter and voltmeter. Common use in measurement DC and AC current and also DC and AC voltage. Used to measure AC and DC current and voltage during the practical sessions. Additional function, it also can measure frequency. Number 4, infrared thermometer. It is used to measure heat at instruments such as PV module, inverter, AC and DC breaker, and any electrical equipment. And the last one is solar pathfinder. It is manual method to find and measure the shade at targeted location, inclusive together with sun path charts for 12 months with different longitude. That's all. Thank you. Pass to Mr. Mawadi.
Wow, it's been a great pleasure with the brief and vast explanation by Mr. Fakri, STU1, by me, myself, STU2, and lastly is the solar park by Mr. Hanif Didi. I would like to take this opportunity to thank you all for watching this video, and especially for KKTM regarding Green Building Department lecturers. We'll send regards to you all. Thank you and have a great day.